Hello students, hope that you are taking care of yourself and family members in this pandemic situation. The motivations to come up with this video and actually this channel are my cousins who happen to be higher secondary students going to appear for various competitive examinations. I hope that you will be benefited through this video. Here I have taken up a subtopic of circular motion, that is vertical circular motion. Initially I will start with a particle attached to a string system, and later on we'll put up some questions which can be solved using concepts on similar lines. As we see here, a particle of mass m is attached to a string of length r. This particle is given an initial velocity u. We have to find firstly what is the minimum velocity u such that the particle goes through the कंप्लीट सर्कल. एक्चुअली में हमें यहाँ पे ये पता करना है कि पार्टिकल वेलोसिटी, इनिशियल पार्टिकल वेलोसिटी u क्या होना चाहिए जिससे कि ये कंप्लीट सर्कल करे. एंड एज अ सेकेंड पार्ट we will derive the condition under which it will show pendulum motion. You see here both the questions. In the figure A we see that it should complete the circle, and in figure B what should be the minimum velocity u such that it not minimum velocity, means what should be the condition on the velocity, initial velocity u, so that it completes the pendulum motion. See here, when the particle is given the velocity u at point A, the chances are from A it will go to up to point B or up to C. If it goes up to point C without getting slacked means if the string gets loosened. The thing is, if it goes up to point C without getting slacked, then it will complete the circle and there will be tension in the string in the entire path. कहने का मतलब यह है कि यदि रस्सी ढीली नहीं होती है पॉइंट C तक तो ये कंप्लीट सर्कल करेगा. रस्सी का ढीला होना, स्लैक करना means what? Tension is 0. The moment tension is equal to 0, the string will get slacked, that is, it will loosen. Therefore, we will have to see the region where tension is minimum or 0. We will write the expression for tension in the string in A to B region, this one A to B region, B to C region, C to D and D to A regions. The expressions, means the force balance equation, the tension expressions will show the region where probability of tension getting 0 is maximum. Getting it? Note it down. See here, first we will discuss about the region A to B. See here, the particle is here at this point, and the forces acting on it are the tension T, the gravitational force mg, and centrifugal force mv square by r. I have taken up mv square by r, means I am taking it, saying it as centrifugal because it will be easier to solve it. You can take it as you can say it as centripetal also. I will be taking as a centrifugal force. Getting it? From A to B, you see this one. What is the tension here? Tension T. We will write the expression of forces in the radial direction because it is going on a circular path. Therefore, along radius we will balance the forces. See here, the thing is, to complete the circle, the tension T should be greater than 0. If it is less than or equal to 0, it will slack and it will not complete the circle. In radial direction, what is the force balance equation? Tension T is being balanced by this mv square by r plus the component of mg along the radial direction. These theta are the corresponding angles, therefore equal, means T is being balanced by mv square by r plus mg cos theta. T is equal to mv square by r plus mg cos theta. Now we will see the particle motion in the B to C region. See here again, the motion is being shown here. If it is going from B to C, means Actually it is not going from B to C, it has started from A itself, but in this region B to C, what are the forces acting on it? How to write it? Again, tension T is being balanced by mv square by r minus mg cos theta, or T plus mg cos theta. T in this radial direction, T in mg's component, mg cos theta is also in the radial direction. T plus mg cos theta is equal to mv square by r, or we can write the expression of T as mv square by r minus mg cos theta. Now we will go to the region C to D. Here again, along radial direction, you see whenever there is circular motion, again we will write the expression in the radial direction. This tension T plus mg cos theta here is being balanced by mv square by r. Again here T is mv square by r minus mg cos theta. Please note it down. Now discussion in D to A region. It is again in radial direction. What are the forces? T and this mv square by r and mg cos theta. Here T is mv square by r. T is equal to, T is being balanced, tension T is being balanced by mv square by r plus mg cos theta. Now we have, till now we have seen the forces in the expression of tension T in all the four regions. I'm going to summarize it here. First of all, in the region A to B, T is tension T is mv square by r plus mg cos theta. In this B to C region is T is equal to mv square by r minus mg cos theta. In C to D is mv square by r minus mg cos theta, and D to A mv square by r plus mg cos theta. Now see here what we had discussed. For the particle to complete the circle, the tension T should not be 0. It should be greater than 0. Mind it, this is the key word, key thing here. To complete the circle, the minimum allowed value of tension T should be greater than 0 everywhere. What will happen if it is tension is 0? String loose हो जाएगा, इसमें slackness आ जाएगा और ये नीचे की तरफ गिर जाएगा. You see here, when the tension will be minimum, you see the expressions here, mv square by r minus mg cos theta. You see tension here, it is all in this region. It is positive thing, tension here in these two regions AB and DA, these tensions are positive, but here there is one negative term here in the expression of tension. Due to this negative term, T will be getting minimized. When T will be minimum? When mg cos theta is maximum. And when mg cos theta is maximum? When cos theta is 1 or theta is 0. That is at point C. See here, when theta is 0 means point C, or in this region also, when theta is 0 at point C, means we will have to concentrate the expression of tension at point C. To complete the circle, again tension should be greater than 0 at point C. Means what? From previous equation, this tension T mv square by r minus mg cos theta, this should be greater than 0, which is written here. Means it is greater than 0 means what? T is greater than 0 here. T is mv square by r minus mg cos theta. Means what? From this expression, making this term, cancelling m and taking this g to the right hand side and multiplying it by r, that is v square should be greater than gr. This is the expression number 1. See here, till now we are able to find that velocity v at this point. This is not the initial velocity u, it is velocity v which has changed from initial velocity u. The condition of velocity here should be at point C, it should be greater than gr. But what is the velocity v? We don't know this thing. Getting it? How to find it out? Just think over it. We will find it out using energy conservation principle. You see, आप लोग देखिए यहाँ हमारा कंडीशन आ गया है कि इस पॉइंट पे, पॉइंट सी पे हमारा वेलोसिटी ग्रेटर देन जी आर होना चाहिए. मीन्स वी स्क्वायर शुड बी ग्रेटर देन जी आर और वी शुड बी ग्रेटर देन रूट जी आर. ओके, बट व्हाट इज द वेलोसिटी वी आर? वी नो ओनली द इनिशियल वेलोसिटी यू. हमें केवल इनिशियल वेलोसिटी यू पता है, वी पता नहीं है इस पॉइंट का. वी कैसे निकालेंगे? वी निकालने के लिए हमें एनर्जी कंजर्वेशन प्रिंसिपल लगाना होगा. दिस वी कैन बी फाउंड बाय अप्लाइंग एनर्जी कंजर्वेशन एट पॉइंट्स ए एंड सी. Please note it down. That is, mechanical energy at point A is equal to mechanical energy at point C. That is potential plus kinetic energy at point A is equal to potential and kinetic energy at point C. That is, what is the potential energy at point A? It is 0. Why? We have taken it as a reference level, 0. Potential is 0 here. Initial velocity at point A is u, therefore the kinetic energy is half mu square. And what is the potential energy at point C? It is mg into height. What is the complete height from A to C? It is twice radius, means diameter. A to C distance is 2r, therefore potential energy is mg into 2r plus half mv square. V is the velocity here. We have taken potential energy at point A to be 0. See here, I have not taken work done by tension here. You might be thinking, actually the work being done by tension is 0 here. Why? Because you see, tension is acting radially and it is moving tangentially. Means the work done by the tension is 0 because the particle is moving perpendicular to the tension. From this expression, we have found that V square is equal to u square minus 4gr. But in the expression 1, you see your notebook, we have derived u square, means that V square should be greater than gr. Using that expression 1, V come to this point, u square minus 4gr should be greater than gr. That is, by rearranging it and taking the under root of u square, we get u should be, initial velocity u should be greater than root 5 gr. समझ में आया? जो इनिशियल वेलोसिटी u अप्लाई किया गया है लोअर मोस्ट पॉइंट A पे, that should be greater than root 5 time root of 5 gr. यदि ये इनिशियल वेलोसिटी रूट 5 gr से बड़ा है तभी ये सर्कल को कंप्लीट करेगा. मीन्स इसमें कंप्लीट पाथ में टेंशन विल बी ग्रेटर देन 0. इसमें स्लैकनेस नहीं आएगा और ये कंप्लीट सर्कल करेगा. ओके, सी हियर, मीन्स फॉर दिस एनिमेशन हैज बीन डन. सो कंक्लूजन क्या है? Velocity of the particle at point A should be greater than root 5 gr to complete the circle. Getting it? Means our problem number 1, that what should be the minimum velocity u so that it completes the circle. The answer is the minimum velocity should be greater than root 5 gr, then it will complete the circle. Okay, getting it? Any doubt? You can ask your doubts in the comment section. Now see our problem number 2. What should be the condition on the initial velocity such that it shows pendulum motion like this one? Okay, think over it. If the initial velocity is greater than root 5 gr, definitely it will complete the circle. If it is less than that one, then, but how much less, that we will see right now. Again, the same system here, particle mass m attached to this string, initial velocity u. The question is, find the maximum value of u such that the particle shows pendulum motion. Again, we will write the force balance equations. You see here, pendulum motion is possible only up to this point, because if it will go up to beyond this point, it will show some other type of motion. That is a question that you will have to think over it. See here, this pendulum motion is possible from point D to B via A. Getting it? For this to happen, the velocity should be 0 at point B. Getting it? You see, in the first condition, it should be, for completing the circle, it was greater than root 5 gr. But here the velocity v should be 0 at this point B. Means it should go up to this point, it should stop there momentarily and go back. Here we will apply, you see here, in the previous figures we had used force balance equations. Here velocity v is 0 means what? T is directly is equal to 0. Getting it? Mg is perpendicular to here, therefore we will not discuss it. We will write directly here the energy conservation principle. Getting it? That is, mechanical energy at point A is equal to mechanical energy at point B. Potential plus kinetic at A is equal to potential plus kinetic energy at point B. What is potential PE and KE at point A? See here, at point A this is our reference level, therefore potential at A is 0. What is kinetic energy at A? It is half mu square. Okay. What is PE, potential energy at point B? What is the distance from this point to this displacement? It is r here, therefore the potential energy is mgr plus kinetic energy half mv square. Okay, please note it down. That is half mv square is equal to half mu square minus mgr. Getting it? But what is the thing? Velocity v should be 0, or it should be, final velocity should be smaller or equal to 0. Getting it? From here we get half mu square minus mgr should be smaller than equal to 0, or you see, cancel the mass m, and by rearranging the terms we get u should be smaller or equal to root 2 gr. Getting it? If initial velocity u is smaller than root 2 gr, then it will show pendulum like motion. Getting it? Although in the figure it is showing continuously, but actually in real sense it will not be continuous. It will go up to this point, it will go back, and ultimately it will come here. Getting it? Therefore, what is the conclusion here? The conclusion is, if the velocity, initial velocity at point A is smaller than root 2 gr, then it will show pendulum like motion. Please note it down. Definitely the initial velocity has to be greater than 0, then only it will move ahead of this point. Please note it down. Now see here, we have discussed velocity greater than root 5 gr and smaller than root 2 gr. Then what type of motion this particle will show if the velocity is between root 2 gr and root 5 gr? That is, this is our next question. This I am not going to solve here. You please think over it, or whatsoever you have studied, you again revise it and see here. Means revise the concept which has been shown here and try to derive it. Okay, this is a very good question. And one more question, rather two more questions. Just I am putting up the questions here. The question number 2 here is, a particle of mass m and charge plus q is rotating in a vertical circle. You see, it is rotating. It is given in the question that it is rotating, already rotating. A uniform horizontal electric field E exists in the region. Find angle theta for which the tension in the string will be minimum. Given length of a string and acceleration due to gravity are L and G respectively, and the figure is this. Getting it? The only difference between this question and what we have discussed so far is, here it is given that it is undergoing a vertical circular motion. It is given. Therefore, you need not to think about initial velocity conditions and all those. It is given here. The extra thing which is added here is a horizontal electric field is acting here. You have to find the minimum tension in the complete circle. Getting it? Means what is that angle theta for which the tension in the string will be minimum. Getting it? Try to solve it. The concepts are based on totally what we have seen so far. Simply try to, although this is a very simple question, but you follow the procedure. You write the tension expression in all the 4 regions that we have discussed, keeping in view a horizontal horizontal force due to this applied electric field, and try to analyze the things that we have studied so far. Getting it? You will definitely get the answer. Now, apart from all these things, one more question that I think that you should ponder over that one. See this situation. This is a frictionless surface. It can be a spherical surface or hollow cylindrical, hollow spherical surface. A particle of mass m is put up here. It is given an initial velocity u, and you have to discuss what will happen to this particle if this initial velocity u is given, whether it will complete the circle or not, or means what type of motion it will show. Getting it? The complete question is this one. Please note it down. Discuss the motion of the following figure. Surface is frictionless and radius is r. Mass of the particle is m and initial velocity is u. See here, the question is not, I have not put up the straight question that what is the condition on initial velocity u for the particle so that it completes the circle. I have just simply written discuss the motion of the following figure. You see, it is very important from the point of view of the Olympiad questions also there where they give in very general statement. Therefore I have also on the same pattern I have written, discuss the motion of the following figure. Now you think over it, what are the various possibilities involved here, what known or unknown variables we should take to solve the expression. Getting it? For this you see, just for a hint, how this particle will move, what will be the motion. If it is going complete circular motion, it will be something like this. Getting it? Please note it down and try to solve the question. So we are at the end of this session. I hope that you have understood the concepts. I will discuss the solution of these problems in the next video.